All right, so let's talk some more about rational exponents. So a fractional exponent can have a numerator other than 1, as in the expression b to the 2/3 power, right? So everything we were looking at before only had a 1 in the numerator. And we talked about how that 3 was the index in front of that radical, right? But you can also have a number up here in the top part of the fraction other than 1, like b to the 2/3. You can write the exponent as a product in 2 different ways. So let's talk about all the different ways we can write this. So b to the 2/3 power can be written a variety of ways. And it's really important that you understand this because depending on the problem, it may be easier for the problem to be written like this or like this or like this. Okay, so they can they can move kind of like a fluid nature back and forth. And so as you look at the problem, you just kind of think, okay, which out of these 3 ways would be the easiest way for me to write it? So b to the 2/3 power is the same thing as b to the 1/3 times 2, right? Because if we made this a fraction 2/1, right, and we looked across cancel and then we multiply across, we'd end up with b to the 2/3 power, right? So you can write it like this, or you can write it like this, because remember we talked about the power rule? The power rule, anything inside, if there's that exponent on the outside, that really means the same thing as 2 times 1/3, which is this right here. Or it can be written as, if we take this, which is that 1/3, and we write it, this is the index, we can write it as the cube root of b squared. Okay, do you guys see that? This right here, b to the 1/3 power, that can be written, that's the index, right, of b, and then the whole thing is squared. So that's how they're getting this. So all 4 of these things, this, and this, are all 4 different ways of writing the same thing. Okay, now let's go over here. We have some more different ways. So here we have our b to the 2/3 again. Well, what happens if instead of us calling it 1/3 times 2, what if we call it 2 times 1/3 and we just switch the order? That's the only thing difference here. And you can do that because if you multiply across, you get the same thing as 2/3. So here we would have this, right? And this, we could make it like the power rule. We could put this inside the parentheses and have that 1/3 outside, because the 1/3, the exponent outside, that just means the power rule. You multiply them together and then you get this. Okay, and then while we're at it, if we have this 1/3 on the outside, that is really the same thing. If on the inside we have b squared, that's the same thing as the cube root of b squared, which is right here. So here's 3 more additional ways to write the same thing. So here we have it. We have 1 way, 2 way, 3 way, 4 way, 5, 6, 7 ways to write b to the 2/3 power. Okay, so depending on your problem, you might want to choose any of these 7 ways, because it might be easier. Okay, so what we're going to do is we're going to look at some different problems and figure out which way is easiest for us to solve the problem. Okay, so let's look at this first. It says a number raised to the power of mn, right? So now m is a number and n is a number, okay? And this is referring to the exponent, is equal to the nth root of the number raised to the mth power. So if we have 8 to the 2/3 power, that is the same thing as the cube root of 8, and the whole thing is squared, right? So what I want to see is this index here. I'm asking myself, is 8 a cubed number, right? And there's a couple different ways I can write it. So if I have 8 to the 2/3, I'm asking myself, is 8 a cube number? And yes, it is. It's the same thing as 2 cubed, right? So what they're doing here is they're saying, okay, I'm going to write this is the cube root of 8, but then the whole thing is squared. So I do that bit first. I know the cube root, 8's a cube number, right? It's the same thing as 2 cubed, but the whole thing's going to be squared. And this cube root and that cube cancel each other out. And then what we're left with is 2 squared, and 2 squared is equal to 4, which would be the answer. Okay, so that's one way to solve the problem. Another way to solve the problem is looking at it like this. So 8 to the 2/3. So instead of separating it, what they're doing is they're keeping the cube root here. So we know it's a cube root, right? That's this piece. This piece here is a cube root, and then they're keeping this 8 squared inside. And they're just saying, hey, let's figure out what 8 squared is. And so you do the cube root of 8 squared, which is 64, and then you want to ask yourselves, oh, is 64 a cube number? And the answer is yes, 64 is a cube number. It is the same thing as 4 cubed. And that cube root and that cube number cancel each other out, and you're left with 4 again. So this is a second way to solve the same problem. My personal favorite for this would be this way. So if I have 8 to the 2/3 power, I'm looking at this number here, and I'm saying, hey, is 8 a cube number? And the answer is yes, right? So what I'm going to do is instead of writing 8, I'm going to write 8 as a cube number, which is 2 cubed. 2 cubed is the same thing as 8, right? So I'm going 2 cubed, which is the same thing as 8. 2 times 2 times 2 is the same thing as 8. And that's raised to the 2/3 power. So this is the power rule, which just means I multiply them together. And then what happens? We're multiplying fractions, right? We always look to cross cancel. The 3's cancel out and become 1. We multiply across, and we're just left with 2 squared. 2 squared is the same thing as 2 times 2, which is 4. So this way is one of my personal favorite ways to do it. But yeah, there's really 3 different ways to solve the same problem. Okay? So let's go ahead and look at some examples. So this first example here. Okay. Let me get it here. So we have 81 to the 5/4 to the 5/4. Okay? So when I look at this, I'm looking at this number on the bottom, and it's to it's the 4th root. So I'm asking myself, is 81, is that a number that can be written to the 4th power? And so let's look at my numbers to the 4th power. And yes, 3 to the 4th is the same thing as 81, right? And hopefully you guys remembered that. So instead of writing 81, I'm going to write 3 to the 4th power. And then what I'm going to do is just the power rule. So, because 3 to the 4th is the same thing as 81, and 81 is being raised to the 5/4 power. So then I'm just going to do that multiplication. 3 to the 4th times 5/4. And then what happens? We look to cross cancel. The 4's cancel out, right? Multiply across, and we're left with 3 to the 5th, which is the same thing as 3 times 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is, I know this is one of our ones. What is 3 to the 5th? We figured that one out. What is it? 3 to the 5th is, what is 3 to the 5th? 3 to the 5th is 243. So that's our answer, 243. It's just so much easier if you have them all memorized. Okay, now we're on to this one, B. So what I see with this one, this is a big number, okay? I'm gonna change up my color. I see that this, I wanna know, can this number be written as a 5th root? So what I'm gonna start doing is I'm gonna start writing up all of the numbers written to the 5th power. So like 1 to the 5th is 1. 2 to the 5th is, what do we say, 32? 3 to the 5th, we already had that one. What was 3 to the 5th? 3 to the 5th was, well, we just did it. 3 to the 5th is 243. And then I'm just going to keep going. 4 to the 5th. Oh, gosh. Okay, 4 to the 5th is going to be 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5. Okay, so that's 16. 16 times 4 is 64. 64 times 4, or how about we go 64 times 16, because 4 times 4 is 16. And then it's 64 times 16. So 64 times 16 is, 6 times 4 is 24. Write the 2. 6 times 6 is 36, plus 2 is 38. Write the 0, that's 4, that's 6. And then we just add. Okay, 4, 2, that's 9, 10. Okay, 1,000, okay. 4 to the 5th is 1,024. Okay, it still needs to be bigger. So let's go 5 to the 5th power. Okay, 5 to the 5th power is going to be 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5. Okay, so what do we have? We have 25 here. 25 times 5 is going to be 125. And then we have 5 times 5, which is 25. So if we figure out what 125 times 25 is, then we'll know what 5 to the 5th power is. 125 times 25. 5 times 5 is 5. Carry the 2. 5 times 2 is 12. 10 plus 2 is 12. Okay, where was I? 25, 2, 10, 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. Now I'm here, add a 0. 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. Okay, so we got 5, 2, 6 plus 5 is 11. Write the 1, carry the 3. And there we have it. 3,125 is the same thing as 5 to the 5th power. Perfect. So what I know is instead of writing 3,125, I can write that is the same thing as writing 5 to the 5th power, and then I'm going to times that by 2/5. Okay, so I have 5 to the 5th power, then it's just the power rule. These get multiplied by each other. And what happens? These cross cancel, and we're left with multiply across. They become 1, right? And it becomes 5 squared. 1 times 2 is 2, divided by 1 times 1, which is just 1. 2 over 1 is the same thing as 2. And then 5 squared is the same thing as 5 times 5, which is 25. So there we have it. That's the answer, 25. Perfect. Okay, now it is your turn, ladies and gentlemen, to check it out. I want you to try A and B. Here's my friend, the Pause Dragon. Remind you to pause your device. When you get done, press play, and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. So, I'm looking at this number on the bottom. This cancels out numbers written to the 4th power. Is 16 a number that can be written to the 4th power? The answer is yes. 16 is the same thing as 2 to the 4th power, right? Back here on our numbers to the 4th power, 2 to the 4th power is the same thing as 16. So instead of writing 16, I'm going to write 2 to the 4th power, and that's multiplied by 3 to the 4th power, okay? Then I'm going to do that power rule and just multiply those two things together. And then what happens? We're multiplying fractions. We look to cross cancel. The 4's cancel out. And we multiply across, and we're basically left with 2 to the 3rd power. And 2 to the 3rd power is the same thing as 2 times 2 times 2, which is equal to 8. So if you got 8, great job. Okay, the next one we're going to look at is right here, 1 to the 3/5 power. So I'm going to ask myself, okay, is 1 a number that can be written to the 5th power? And yes, it is, because 1 to the 5th power is the same thing as 1. So I can go 1 to the 5th power, because 1 times 1 times 1 times 1 times 1 is the same thing as 1, and that's raised to the 3/5 power. Power rule, we go 1 to the 5th power times 3/5 fifths, so 5 times 3 fifths, make that a fraction. Look to cross cancel, they cancel out. Multiply across, we get 1 to the 3rd power, which is the same thing as 1 times 1 times 1, which is 1. All right, that is it for that. If you got that right, great job. Okay, this is our last problem, C. So I want you to go ahead and try this one on your own as well. So go ahead and pause. When you get done, press play and we'll talk about it. Okay, let's see how you did. So what I'm doing is I'm looking at this bottom number in the fraction. This, I know that it cancels out cube numbers. So I'm going to ask myself, is 27 a cube number? And the answer is yes, 27 is a cube number. 27 is the same thing as 3 cubed, right? So I'm raising that to the 4/3 power. So instead of writing 27, I'm writing 3 cubed because it's the same thing. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27, right? So these are the same thing. Now I just do the power rule. I multiply them together. Okay, and then make this a fraction. Cross cancel. The 3's cancel out. I multiply across. I get 3 to the 4th power, right? And 3 to the 4th power is the same thing as 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. And that's the answer. So if you got that one right, boom shakalaka, you're doing a great job. And I'll see you in a little bit for example 3.